So this is the new homepage for Data.table. So again, if you just go to r-datatable.com, and it'll auto-direct to this homepage. And then this is the link, the Slido link in the middle. I'll make it a bit bigger. And my mouse. So if you click Slido and then enter the event code, ask Matt Dowle, it'll take you to this site. And I advertised this over the weekend, so we've got a few questions already. I'll come back to that at the end of the talk, but if you'd like to ask questions now, just put them into there. So this is a new website courtesy of Package Down, thanks to RStudio and Hadley Wickham for both producing that package and making it available, and helping us on the Data.table team for creating it. Hadley actually put a lot of effort into tweaking it and making it work. And so what is Data.table? It's been around 13 years. It's an enhanced version of data.frame in R. And it's, I think most people have heard of it now. It's concise syntax. And I just want to go, it's not really, I'll make it a bit smaller to get over to the right-hand side. We've lost the tab on the right. Let's see if we can find the tab. Where's the tab gone? Okay, so it's a sizing issue with this. We can see the right-hand side. It's okay on your screen. And if you scroll down to the bottom, then we've got a live status on CRAN. It is pretty much okay at the moment. There's 1.12.6 released last week. It's passing on all machines, and it's just a Windows, one machine failing on one machine, but it's all available. And build passing in dev, code coverage 99%. It's about 10,000 lines of C code. Well, 10,000 lines of code, half of it's C, half of it's R, something like that. And nearly 600,000 downloads per month. 750 CRAN packages using it, 190 bioconductor packages using it, and directly, and then packages which use those packages which use Data.table, over 2,000 on CRAN. So one of the things I have been asked is when you click all authors, you've got a list of all the people who've contributed to Data.table, but not Hadley Wickham, because he's contributed this website itself and helped us out. And the reason for that is that this contributor list isn't just kudos and thanks, but it's a legal thing. So these are all the people who have contributed code, either one line of C code or one line of R code. And if we change the license of Data.table, then I have to ask everybody who's ever contributed in the past whether it's okay to change the license. So when you contribute to Data.table, you become a joint license holder of the package. And indeed, this did happen last year, actually 2 years ago, and we did change the license from GPL to MPL, and I did go and ask every single person, was it okay? So all these people have agreed to the change to MPL, and basically MPL is lesser than the LGPL. It's not a GPL license. It's the lowest license we can go, where we have this concept of the community and the contributors owning the code that they contribute to. So this follows on from what Sri was mentioning in his keynote about open source development and open source culture. So if we go to the Py.datatable project, if you search for Py.datatable, you find the H2O.ai project on GitHub. So that's open source too. And if you scroll down, You see all the code is front and foremost, all the badges, descriptions, so on and so forth. It's similar to Data.table in terms of the IJ by syntax, but it's more advanced in the LLVM optimizations and the out-of-memory memory mapping. And it's 64-bit by default, and it's already done. And it's easy to install, just like Data.table in R. But I like right at the bottom, you have to scroll all the way to the bottom and then click the documentation, and then you get this very nice documentation page. So this is where to start with Py.datatable in Python. And so we can see some of the syntax, and so this is the syntax of Py.datatable in Python. So like Data.table, train df is a data frame, and then you can use the price column as a column name, and you just prefix it with f dot. So this is, Py.datatable is all done by my colleague Pasha and Oleski, and they, I haven't done this is their work. And one of the nice things that Pasha has done is a function called export names. So if we look for export names, which I searched for before, which is why it came up, then hopefully, let's see. I think it just came up with that page because it was already on that page. So what you can do is call this function, export names, on the data frame, and then you don't need the f dot. So you don't have to pepper the J expression with f dot all the way through, which is one of the things we like in Data.table in R2, is that we don't have to have that prefix. So this is just what I'm highlighting here in orange, ID, price, quantity. These are all columns of the data frame. Price times quantity is an expression which is evaluated and compiled to LLVM and all done very fast. So this is basically Data.table syntax in R in the same way. So if we go to some benchmarks now, so back on the R Data.table homepage, we've got the links at the top, the manuals, the vignettes, the change log. I'll go through that in a second. The benchmarks I wanted to spend some time on. So I have presented these before, and they have developed over time. So recently, last week it's been changed to be 2 tabs here. So it's group by and join. And then just the largest size we're doing at the moment is displayed here. Before, we had this, if we go to this tab, we had 3 tabs for half a gig, 5 gig, 50 gig, and then we saw the same out of memory on the other packages, but then you could also see where they worked and where the timings compared. So the idea is that we have 3 sizes, 2 that fit on a laptop and 1 50 that fits on a server. So they're all 64-bit packages in terms of being able to fit 64-bit of memory into a data frame. And then we compare these 5 grouping tests. So the 5 tests are low cardinality, so a few big groups, and then high cardinality, lots and lots of very small groups. So that's question 5, and question 4, and question 3 are the high cardinality tests. So we have 5 different questions, grouping, and then we run each query twice, just twice. And we report the first run and the second run. so that you can see the difference the second run makes, because many of these systems cache results, they automatically index the data, and another feature is because we have such large data, it just takes too long to run more than 2 runs. So it takes 70 hours to run all the tests on this page. So following from the previous presentation where the speaker was talking about truncation and bias in your results, that's what we're trying to avoid here, because the truncation you see in the blog posts and in online benchmarking is you often see a violin plot of 100 runs and very nice distribution with the mean and the standard deviation and a few outliers. And what's the funny thing, what's the unusual thing about that one outlier at the top of the violin plot? It's the first run. The first run is always the slowest run. And when you're a data scientist getting your job done, how many times do you need that answer? Once. So why are we repeating the benchmark 100 times to get a very nice mean and standard deviation when really we just want it to answer once? And those 100 runs are done on small data because it's too long for the person writing the blog post to run. If it's big data like 50 gig, it would take 3 weeks. It takes us 70 hours just to do 2 runs. So they make the data small. They truncate the data science exercise of benchmarking. And so those benchmarks are appropriate if that's what you do. If you do have one data set and you want the same result 100 times, then that benchmark is appropriate for you. But if you have 50 gig in memory and you want the answer once, then this is the benchmark that's appropriate for you. And you want to know how long does the first run take and how long does the second run take. So that's the biggest difference here is ClickHouse on this first question, where the first run takes 84 seconds and the second run takes 2 seconds. Now what we're trying to do here is be totally transparent, thorough, and fair by presenting both numbers. So now you see that I would say this is very, very good for ClickHouse because it is automatically indexing and summarizing the data and caching intermediate results so that it can reuse it on the second run. And you can see that the second run for ClickHouse is much faster than Data.table. So depending on your use case, you can take these results and apply them to your situation. That's our goal here. So the first time is a bigger square, so that's the wider bar, and then the second time is the thinner bar so that it fits on top with a slightly different color. So we have 5 tests, each repeated twice, and then we sum up the 10 numbers, put them in the table. So these numbers are the sum of the 10 runs, and then it's sorted by time. And then we put, and it's not a blog post because it's updated regularly. So we have the date of the package, so we use dev versions, the version that we're testing, so Pandas is the latest 0.25.1. It's one image, so this is an image PNG, and in the bottom right-hand corner is printed the timestamp, so that you know whether it's stale or it's been updated. We did think about making it a more advanced website with filters and able to draw graphs on the fly, but what we found is that the browsers cache the results and end up with bugs in the browser rendering mechanisms. Differences between browsers come into play. We have to tell people to do Control F5 to refresh the results. So we put everything into one PNG so that it's self-contained and consistent within that PNG. And all the results are in one huge PNG file, but it just displays on screen reliably. And so you can see the systems that we are testing against. The other thing to note is that, of course, Data.table will fail if you have more than 2 billion rows, whereas ClickHouse will work, Spark will work, and Pandas will work, because they do cope with more than 2 billion rows on a big memory machine. So people often say, well, just get more memory then, and then those systems will work and they won't be out of memory. Well, that's true too, but we are trying to measure somehow what the breaking point is so that you can gauge. So that's on grouping. And the other thing is that these tests are very old. They're 5 years old, and the first tests I did 5 years ago are still on the original homepage. They're down here, and those were just, in those days it was just Data.table, dplyr, and pandas, and so we've left those results back there. So nothing's changed with the data or the queries. It's the same tests that have stayed constant for 5 years. So we haven't done any cheating in that way. And then the recent new addition is adding joins. So if we click join, then we have another set of 5 questions, and we vary the cardinality and whether it's small groups joining into big groups, duplicates, and those kinds of features. And then we again add them all up and then compare the results, and the results there. We update every time these packages update in dev. How are we doing for time? Okay, that's benchmarks. So on the latest news, where was it? So in the change log, so we can scroll down this. 1.2.6 was 12.6 was just a bug release last week. So in 1.2.4, 1.12.4, there were 29 new features, 46 bugs, 225 PRs from 24 people, and I was going to just scroll through them and pick out main things. So fread has some extra skipping nulls has come up a lot. Lots of more like minor things, but just add up to be quite a bit. Fwrite, writing compressed files directly so that you don't have to write the big file intermediate first. It just compresses on the fly. So that's a contribution from Philippe, and that's been great. And I think I wanted to mention that one person, Michael, he's contributed 80 PRs in this release, but it doesn't really come across in the news file because a lot of his PRs have been coverage, huge amount of coverage additions, which are really important when it comes to what I was doing yesterday, which is increasing the number of rows to be more than 32 bits. So given we have 99.9% coverage, then we can rely on our tests covering all the lines of C and R code. It's not sufficient, but it's necessary to have 100% coverage. We tried to do the most requested features first. So fwrite, being able to turn off scientific precision, has been requested a lot. So that's in this release. And if I didn't mention it before, the benchmarks are all done by Jan Gorecki, who's also a H2O employee. He's part-time and does his MSc at the same time, so he's half-time. And so many people are involved. So, enough time for the questions? Just to finish them off, because I did promise that I would answer them. Let's see. I thought I left that tab open. See not. Oh gosh, you all did ask questions. Right, let's take it from the top then and just work down. So SAS has disk-based data processing. Will Data.table adopt some disk-based mechanism? Well, yes, we'd like to memory mapping in a similar way that Py.datatable already does. It wouldn't be chunk, process it, and write it to disk. It would just be memory mapped columns. Have RStudio ever suggested to incorporate Data.table devs into the official family alongside Tidy, and would you consider such? I don't know what that means really. Does that mean RStudio employing Data.table devs, or I don't know. But they have the DT Ply.R project is a layer above Data.table, and Hadley's and his team have put a lot of effort into that recently, which is much appreciated. So it is integrated into RStudio in a much better way now. So that you can use Data.table from Ply.R, dplyr, without needing to know Data.table syntax. In our Data.table, what strategy do you follow or suggest when facing the n-row Data.table greater than 2 billion? So I saw that over the weekend and started working on it, and flying over here and last night, hoping to get it done for this presentation, but didn't quite make it. So I'm nearly done. Hopefully, maybe in a week or so, that'll be done. How well Py.datatable matches up with its R prototype in both features and performance? Well, it's pretty much there. Grouping, joining, grouping by 2 columns. It gets good feedback. It's integrated into driverless AI. So all the things that you see in driverless AI are being done by Py.datatable in Python. But everybody's got their own requirements and their own tasks. So I just suggest giving it a go. Is it possible to use Data.table from a C application by using RC shared library? Are there any examples? Well, if that was you, Dirk, then not yet. I just don't know how to do that. It's been asked from RCPP. I don't think that's very high priority, but if somebody would want to do that and contribute it, then we'd have, of course, put the PR high priority. Could there be resource for contributing to Data.table for newcomers, preferably aimed at a large audience with a little bit? Well, there is already a link. Actually, I haven't seen these. Are new questions. I haven't seen these. But contributing, this is on the old homepage. So you can contribute by filing issues, pull requests, coding style, some testing. But right at the bottom, here's a minimal first-time PR. So this is all the things you have to do with a focus on being on Windows 2. And that's what you have to do to contribute. And all the, we have tons of issues. So you could pick off one which is kind of quite small, maybe, and we'll try and help where we can. But yeah, the contributing page is where to go. Is there any plan to have compressed data columns using FST or similar compressing lib that could deflate compress as needed for computations? That would, I think, greater than 2 billion rows comes first, and then on disk next, and then compression after that. What are the constraints in having GeForce optimization applied to any kind of computation done on J when grouping using by? So it's only simple grouping commands, like if you do mean by a column, then that's GeForce optimized, which means that you don't really run anything by group. It's doing everything. All the groups are done in a single pass at the same time. So, but as soon as you do, if you said mean of v plus 1, then that's an R expression, and then the optimizations can't apply. So that's one constraint. So you need to use verbose equals true, see if the optimization is on, and then know that, then don't do 1 plus 1, and simplify the initial query, and then do your plus 1 afterwards. So that's one of the things that the LLVM optimization in Py.datatable is solving and is better at. Colon equals the walrus operator. Well, That's the new walrus operator in Python that's just introduced this year, I think. What's the sea lion doing on the table? So, okay, so the sea lion, what does sea lion say? All together now. R. That's why it's a sea lion. That's all I had. Thank you very much.